I'm Nick McMillan, and this is my MEMS 5001 final presentation. I will be discussing the topology optimization of an ice skate blade holder. Just as a little introduction, the ice skate blade holder is the plastic part of an ice skate which connects the boot to the metal blade. There are currently two iterations of this product on the market, one from CCM and one from Bauer. My project is to minimize the mass of this part. This is important because the NHL is moving towards lighter and lighter equipment, and a company that could provide an optimal mass minimized blade holder could monetize that quite well. A little background. One piece of research, previous research that I relied heavily on, was a 2015 study of on-ice biomechanics of ice skating and hockey. This study looked at multiple measurements of movements, with the most relevant measurement being the forces involved on the feet. This was accomplished by a pressure-sensitive insole, which was then divided into 5 regions. These 5 regions were then tracked and graphed, as you can see on the right. These forces were extremely useful in developing a model for the optimization. To develop a model, I created a rough model in Autodesk Inventor. Accuracy to a current product was not necessary, as most of the material would be removed during the optimization. This model was imported into Altair's Inspire, and a design space was created. A load case was also developed using the peaks of the previous data. These peaks were used to account for the impulse-like forces experienced in skating. Since the data was given in newtons per kilogram, the average weight of an NHL player was used to determine the point loads. A material of ABS plastic was used, as this is an industry standard, and a factor of safety of 2 was also used to account for any players with an above average weight or any extraneous forces which were not considered. This is a discrete search space, as the program can only run a finite number of iterations. The results, the current weight of Bauer's tuck holder is roughly 0.2 kilograms. The optimized weight of the holder, which I found, was 0.127 kilograms, which is 36.5% lighter. On the right, the upper image is the actual result of the mass minimization topology run, and the bottom image is a polynerbed model. This smooths out any rough edges and makes it more manufacturable. To continue work in this topic, one should consider the manufacturability of the product. This product would most likely be produced through a injection molding process, so any relevant variables related to that process should be considered. Also, replaceable blades are a common feature in this product. This is usually achieved through a screw system, which would be pretty easy to implement in the optimized product. Also, miscellaneous forces should be accounted for in any future studies. This could be anything from errant pucks to the blade, or hard stops, or a number of other things. Due to time constraints, I did not look into these, but they should be considered.